So we have Professor Himadri Chattopadhyay with us. Moving ahead with this academic session, it gives me immense pleasure to introduce the expert for our first lecture, Professor Himadri Chattopadhyay, Professor of Mechanical Engineering at Jadavpur University. Before joining Jadavpur University, Professor Chattopadhyay served as a scientist at CSIR, Central Mechanical Engineering Research Institute, Durgapur, and also served as director of the School of Bioscience and Engineering at Jadavpur University for 2 years. Continuing with his remarkable journey, Professor Chattopadhyay has authored over 350 research papers, served as an editor for Helion Mechanical Engineering, and guest edited special issues for reputed publishers. His research spans thermofluid sciences, CFD, turbulence, and heat transfer augmentation, jet impingement, bioengineering, materials processing.
Am I audible?
Yes, sir.
Hello?
Yes, sir.
My screen is visible.
Yes, sir.
Somehow I am not getting good sound in my this thing laptop.
Okay,
Anyways, I'm going ahead. Okay.
okay,
So
sir. I
just a
would
minute.
request everyone to mute their mic and shut down their video also. When the lecture will begin, please kindly mute your audio.
So I hope I am audible. Let me share my screen. Screen is here.
हौलदार हौलदार ठीक है हो क्या 7 बजे
Kindly mute, sir.
1 minute, just 1 minute. Give me a minute. Intervene advance. Okay, so I hope you can see the screen.
Yes, sir. It is.
Okay. So, very good evening. Uh, we are now starting the course on energy sustainability and climate change. So, the first topic that we will be discussing is from the renewable sector. So, basically, the wind energy. So, I have made it in two separate presentations. One, I'll talk about the tidbits of wind energy. What are the progress of the technology, where are we, what are the research issues, and then we'll examine it from the context of sustainability, as sustainability has become a buzzword, is becoming important in day-to-day life because of the policy implications, and also because of the the question of the continuity of human being. We all know that extreme climate events are very common now. Like Punjab is flooded. There are so much of water in Gurgaon and Noida that people are actually using boats. Now, Kashmir, Uttarakhand, there has been huge floods, and even Rajasthan, where water is a scarcity. Now, last few years, it is regularly facing a lot of heavy rains, which is affecting the people. So it looks like climate change is a reality. Like people prefer to travel to Europe for the comfort in the summer months because the climate used to be very good. Now you cannot imagine Spain or Greece. Temperature has risen to the extent that the life has become unbearable, and they are not habituated to that. So yes, climate is hot somewhere. So Dubai, it is always hot, and it's cold in say Antarctica or Canada or places. So we get habituated to a particular climate. So
Mu.
even say 30 to 33 degree, that is becoming a big challenge for Europe. They don't have fans at their homes. So climate change is a reality. For example, one of so such things forces us to examine that what is our uh, way of life, where we can do something to improve the life, to improve the continuity of the human being and the situation of the planet. So as I said, that we are facing a big challenge. So we need more food. Population is growing up. Like now India has surpassed China. We need more energy and much better environment. And already I talked of global warming, that three topic extinction. Because you see that the way it is going, uh, the ices in the polar regions are melting. So that melting will can raise the sea level. So the places by the side of the sea uh, can submerge in coming days. And then the pattern of agriculture, the pattern of means other sources for sustenance like fish and animals, everything will eventually change. So that is a challenge for human being. Even the extinction is even not unthinkable. So there is has to be a need to fight against this challenge, which requires awareness and actions. So we'll all know that global warming pattern. So global warming, if you look at this thing, so there is some certain randomness. So there is some randomness. It is however, the overall trend is that temperature is rising. So if you look into the world, this is predicted to be something near 2 degrees Celsius, and maybe in our country it will be somewhat less. But there is a climate clock which is ticking, and there is a consensus that we should limit the global the rise in temperature to 1.5 degrees Celsius. So this data is from Intergovernment Panel of Climate Change. So there are panels from different countries who are working together to fight the global warming, climate change, and then uh, uh, the war of the battle of sustainability, so that human being along with the other members of the flora and fauna can live a better life. So human being have understood that we are not alone in the world, and our life depends on so existence of other species, flora and fauna. See, in this context, for example, take the example of bee. Like bees are responsible for the fertilizations in plant, in flowers of the plants. So if the life of bees are damaged or threatened, there is problem in pollination. So there will be no more paddy or rice or fruits or foods. So like, but because we are spreading so much of insecticides, that the number of bees, the population of bees are declining. So in fact, even in West Bengal, people are going to the field and just giving some movement to the paddy field, or the field of say sunflower seed, that the pollination becomes easier. So which was done by environment is now not so, means so abundant because of our uh, excessive usage of pesticide, unplanned so we must understand that what are the consequences of anything, any technology we embrace, and it will eventually affect. Like all of us know that price of, we are talking of mainly, I'm talking of wind energy, but in this context, see that the type of rice we normally consume, the price has gone 2 to 3 folds in recent few years. So things are becoming scarce, and all of us are suffering. and particularly people below the poverty line, they are suffering more. But nevertheless, we have to fight for against that, and for that these issues becomes important, and they reflect in different sectors, be it energy, be it agriculture, be it water usage. We have to understand the context of the environment and how the health human being are related to that. So now therefore renewable energy has become very popular. So what people have found, of course, this is well known that energy consumption is the measure of prosperity and well-being. So which country tops the list of well-being or more prosper, that depends on the energy consumptions. So per capita energy consumption, that type of list is published to assess the economic situation. However, the conventional source, like we all depend on coal-based power plants, and then there is fossil fuels like petroleum. So that is also a major source for automobile and many industries. And there are issues of pollution, and also this supply is not inexhaustible. So this is some sort of limited resource. Now renewables are a viable alternative with abundance. So like wind will be there, the sun rays will be there, the water and the sea waves will be there. So there are a lot of supply of that. So therefore they are renewables, and they can act as a viable alternative. So and they measure one of the major advantages, the pollution is less, and the source is also economically viable. So therefore renewable is becoming more and more popular. So like countries like India, still we depend uh, mostly on coal based thermal plants. But if you go into Scandinavian countries or Europe, many of them have switched to renewables, and almost 90% or more than 90% renewable energy are being used. So India is also uh, stepping ahead to increase the share of renewable as a part of the climate change combat strategy, and to fight against global warming. India has also understood that our share, what we call is energy pie. So our share in the energy pie or renewable should be increased. So that is going on. So it is not that renewable energy is everything bliss. So there is the question of what we call intermittency. Like your solar panel will not work if the sun is not there, or it will not work in the it will not work in the night, or there is a cloud cover, and say sun is available for number of hours in summer, but in winter you will get fewer hours. And for example wind energy too, like winds, even if some place may be windy, but it does not guarantee that 24 hours there will be, so there will be good supply of wind. So wind is also stochastics. There is sometimes it will be high wind, sometimes it will be low wind, sometimes there is what is called wind drought, not enough wind. So like solar, wind is also having some the issues of intermittency. And even if you talk of water, say the water based plants, hydel power plants, even water is also, you know, that there is sometimes scarcity. The supply is not in the level we think a priori, that this much of supply is always available. That may not be true. So I already told that I'll first talk of some wind energy technology, and then talk about the sustainability. That sustainability is not so easy to assess even for in renewable technology. So first of wind turbine. So basically wind turbine is a uh, energy converter which requires a portion of solar energy, because all of us know that because of the sun rays, the heat that carries, that actually produces the field which moves the wind. So in a way wind energy is again the contribution of the sun god. So uh, so wind related one terminology is windmill. like ancient civilization of Europe, you'll find lot of windmill. So windmill is not a wind turbine in the sense it does not deliver electricity. Windmill produces some other work, like you can grind wheat or barley, or you can do pump water. So if you convert energy to electricity, then it is a wind turbine. Otherwise, we call it a windmill. So there are two type of wind turbines. One is horizontal axis wind turbine, which is like a table fan. So the axis of the turbine is horizontal, and there are a relatively less number of vertical axis wind turbines. So the axis is vertical. It is like an inverted ceiling fan. So the axis is like this. So these are two type of wind turbines. Like,
అది మా అమ్మ పంపించిన షాంపూ
and
నానా
everywhere you can see horizontal axis wind turbine along the coast of say seashores,
ఈ
and
మా అమ్మ
also on
పంపించిన
the hills.
షాంపూ నా
So
తెలీదు
world
ఏదో
over, if
తెలీదు
you
ఒకసారి అడగాలి మా అమ్మ
go by some
చేద్దాం ఒకసారి
transports,
మా
say
అమ్మకి
planes or trains, often you will see the landscape is filled with horizontal axis wind turbine, and it is, for example, they are coming from the sea surface.
లోషన్
So
నాదో
they are
షాంపూ
immersed in the sea. So you can see there are huge blades, and they must face the direction of the wind. And this area is called a nacelle. So this nacelle mechanism, it helps the wind turbine to face the direction of the wind. So suppose wind is flowing from the right side, so the turbine must face the right side. So this is one of the features of horizontal axis wind turbine, and there is a mechanism, gear driven mechanism, so that does that. That is called a nacelle. Now this is a vertical axis wind turbine. So this is mounted on a shaft which is vertical. The axis is vertical, and it may have many different designs. So for the sake of just showing, I will show you different designs, and you can see that this is a vertical axis wind turbine with complex blade shape. So advantage here is that it does not need to face the direction of wind. So unlike horizontal axis wind turbine, it must face the direction of wind. If the wind is coming from direction, it should face this direction, and like it should go to this direction if the wind is coming from left. Like we tell that a sunflower tries to face the sun, so a horizontal axis wind turbine has to face the direction of flow. But vertical axis wind turbine, this is basically a circular pattern in around a vertical axis. So anywhere the air comes, it will be tangential. So it does not need to orient along the direction of the wind. So that is one of the advantage of vertical axis wind turbine. But mostly horizontal axis wind turbine, they supply more power compared to vertical axis wind turbine. They are more efficient, and vertical axis wind turbine, they work for when the velocity of air is low. So where I have lot of air supply, I should go for horizontal axis wind turbine. They are more efficient. And if I want to tap the energy, say from my roof of the building, so if it is a high-rise building, from the roof there is a lot of flow is going. I mean, some flow is going. However, then I can use some vertical axis wind turbine. So some designs, you see that they have different designs. So my lecture is not for a in the sense that we'll look it from pedagogical point of view, but rather I want to make it interesting in an overall sense. So without going into technical details of the parameters, I just mentioning the main features. So there are basically drag type and lift type of wind turbine. So like drag type is like buckets. So like you have seen Pelton wheel. Pelton wheel lift the air hit. I mean the water hits and the Pelton wheel rotates. Similarly, drag type turbine, they make mainly is the air will hit and it will rotate. But in lift type, the profile is such that it produces lift action and then it rotates. So it is like an aerofoil blade. However, there can be a lot of designs. You can see the different type of horizontal axis wind turbines are shown here, and this is the reference from where these designs are collected. Now you can see that these are vertical axis wind turbine. So for example, that is mounted on a tower and they have these carved blades, and these are different designs of vertical axis wind turbine. So Darius are basically lip type wind turbine. So they operate, you see that this have aerofoil type shape. So the high level of lift is generated, which helps it to rotate. You see that because energy is an important commodity everywhere, people are trying to capture whatever energy is available. So if you look into the Boston airport, so Boston airport on the roofs, there are a number of turbines. So for capturing the whatever energy is there. So for example, you may be aware that in Kolkata airport, lot of solar panels has been installed in the runway area, because runway there are some paved roads, but there are a lot of space where planes don't go. That is just like field full of grasses and all. So one part of the runway is covered with solar panels, and therefore it is possible to supply a large part of the energy required for the building to be supplied from the panel. So similarly, often this is a strategy to harvest energy from the flowing wind from the top of a building using certain turbines. You see one clever design, windmill on highway. So these are the two wind powers. So, I mean wind turbines. So there is normal air plus the vehicular movement that also creates some flow field. So this can be highlights. This can provide energy to these turbines, which can generate certain limited amount of energy, and they can feed, for example, directly to the traffic lights. Traffic lights need energy, and it can be fed from here. So like sometimes you combine, so wind energy blade actually is a research area. You can do many things here to maximize your energy availability, and therefore combinations, like you can use different type of airfoil shapes for the wind turbine blade, and sometimes the Darius type, which are lip type wind turbines, and Savonius, which are drag type or bucket type wind turbine. So you can combine them. Like these are like simple drag type. There is no blade angle or anything, just strips. But here there are some aerofoil shapes designed. So together they can harness more amount of energy. So this is again, I said, an interesting area where you can just try to increase the efficiency. So this is one of the classification when you talk of windmills or wind powers, like 10 kilowatt, like hydel energy also, the smaller, relatively 10 kilowatt, intermediate 10 to 250, and even wind turbines are producing up to say 25-30 megawatts of energy. One single turbine even can produce up to 30 megawatt of electricity. So that is by uh, manipulating the size of the blade, you can have as much energy as 30 megawatt. So the fact is that you need longer blade, and the height has to be also more, because one fact is that as you go along the height, as you go up, the wind speed increases. You all know the boundary layer concept. So near the earth, the velocity of wind is less, and it increases with a power as the height increases. So that is the strategy. But you then and then when you have multiple wind turbines, actually wind turbines, most of the time there will not be a single one. There will be number of multiple wind turbines, which will be called wind farms. Okay, so they are connected to the grid, supplying power to a locality or to a country. So a small one, they are for a remote applications, like for example a remote island, they may have a small or a house in a remote island may have their own dedicated windmill. But such large plants, they must be connected to distributed power, so that it is in the grid and it can be controlled. Okay, So I have some old data. New data is also available, but let me. I have not found the time to make it up very much updated, but it will give you some idea that uh, that wind energy potential is 49 gigawatt at 50-meter height and 102 gigawatt at 80-meter height, and total installed capacity was 22 gigawatt. So now it will be something like 35. So but we have the potential of 100 gigawatt, so we can still extract a lot of wind energy, and see that it is related to the height. If I increase the height of my turbine, the tower, I can extract much more energy. So like you can see that if you look at the global capacity, you see that these are the sector which are growing: hydro, wind, solar, bio, and others, out of which that wind and solar are growing very fast. Like wind energy, if you look into this is current data worldwide. You see that almost 1,000 gigawatt of energy is produced in 2022. So by today it will be another 500 gigawatt. So it is actually exponentially growing as the card is the plot depicts. You see 2002 how much was there? Only 31. So in 20 years it has grown 30 times. So what is the thing is that India, okay, here I have up to 272, so 32 gigawatt I already told. And if you look into the state-wise capacity, India, which are the best state, Tamil Nadu, so Gujarat, Maharashtra, Karnataka, Rajasthan, Andhra Pradesh, and coincidentally, this some of them are also very good in solar, like Gujarat and Rajasthan. They are also producing a lot of solar energy also. And when renewable energy grows this fast, naturally what happens, the cost of energy comes down fast. So that is very important, because people will not go for something which is costlier than the available technology. Whatever is the merit, the cost must come down, and that is, we'll talk about that is also an aspect of sustainability, that cost is uh, given its due importance. And now we can safely say that cost of electricity per unit for renewable energy and coal-based power plant is at par. So that is why the countries abroad, they have almost phased out coal-based thermal power plant, and also India can make strategies to go for replacement of coal. Of course, in near future, coal cannot be replaced, because we the
तो ये दिख तो नहीं रहा
country
होगा ना हम लोग
huge population, lot of power requirement. So, and the supply of coal is also there, so it will be there. But we can afford wind energy as the sizes of the plants are increasing. Eventually, cost has to come down, which has happened, and which is giving us the advantage. So state-wise, let me skip this. Like there are tables. You see, you can find this in Ministry of Renewable Energy, non-conventional and renewable energy. They publish report everywhere, and you can see that how the states are growing in different sectors like solar, wind, hydro, and bioenergy. But the thing very interesting is the size of wind turbine. You see that the wind turbine is a very big machines, typical wind turbine. So you see that is the diameter of the rotor is something like 413 feet, so almost like a football field. Okay, so one of the huge structure day to day we are habituated to see is an aeroplane. Aeroplanes are huge. So still larger are the wind turbines. So they are actually growing very fast, becoming very big entities, posing more engineering challenge, technical challenge, sustainability challenge as well. So we are talking of wind energy, but this is greenhouse emission. I'll skip that. So So in context of renewable, this is important to mention about, sorry, just a minute. Yeah. So this is important to mention about the India's pledge in, you know, that there is a conference of parties. So this is a climate related event. So from, for example, it is represented by the Prime Minister of India uh, and other departmental representatives from different ministries. So we have a promise to have net zero emission by 2070, and by 2030 our promise is to develop 50% energy from renewable. And however, one positive fact for India is that we have almost 1/5 of the global population. Of 5%, every 5%, 1% is Indian, but our emission is only 4%. So that means per head emission for Indians are very less. So uh, that does not mean we should not work on renewable, but that means we have some leeway, we have some more area to work on, and we can still continue for some time to have carbon based, hydrocarbon based, coal based power plants. So this conference of parties, they are given a lot of weightage, like India says solar energy is 17 times in 7 years. So similar figures I have shown for wind. Wind also, it is going very fast, and the net zero is placed by 2070. So now talking of wind, can we put wind energy everywhere? So like we need something that power density. So watt per meter square, maybe you in that sort of this map shows that which are energy dense. So there it is easier to put wind turbines, and where the flow is not much, wind turbine, only small wind turbine can be used, some vertical axis wind turbine kind of technology on the rooftops of buildings and all this thing. But the coastal area, for example, or the Himalayan areas, you can use where we have higher power density. So wind, we have to remember that wind is stochastic. There are a lot of works on wind speed. So wind velocity changes every minute, every hour, every day, every month, every year. So you will see that even the average wind speed of this year may be 30% less than the last year. So it is highly stochastics. So that therefore, if you want to analyze the data and use the data for engineering design, you have to do a lot of calculations based on statistics. For example, many of you know that why will statistics is used to go for wind energy. So we'll not go into the details of statistics, but we have to remember that this is uh, wind speed distribution in hours. So per hours per year, that means almost 1,000 hours it was average 6 meter per second. So but it can vary, as I said, day wise, month wise, year wise. So very stochastic in nature. And the important physics of the wind turbine, again, will not go into detail, but most of the textbooks gives the basic thermodynamics of wind turbine. As you know, thermodynamics governs the energy. So here, of course, we are not talking of heat, but the energy. So the energy, what is the limiting energy, what is the maximum energy we can subtract? So this is a rotor, wind is coming. So this wind turbine rotor will extract the energy. So naturally the velocity will fall here. So you see wind velocity across the rotor will fall, and then further down there will be less wind energy. So this kinetic energy is extracted by this thing, and you can do, for preliminary purpose, you can do very simple energy. So what is sort of first law of thermodynamics and continuity. So finally you can arrive at a relation that maximum power maximum power of a wind turbine is 8 by 27 density of air, area of the turbine, and the velocity of air, cube of that. So remember that wind power is a wind power varies with a cubic power of air velocity. That means if your velocity is doubled, wind power will be 8 times. So naturally, the area will be there, the density will be there. So density is more or less constant everywhere. Area is how big is the turbine and cubic velocity. So this is the input energy, rho a v1 cube. That is the kinetic energy is half rho a v1 cube. You know the wind energy is kinetic in nature. So kinetic energy half mv square kind of thing. So if you divide this by this, you get a factor of 8 by 27. So you may remember Carnot cycle. So Carnot cycle in power plant gives the maximum efficiency that 1 minus T2 by T1. So no way you can get more efficiency beyond the Carnot efficiency. So similarly, here if you apply the basic fluid mechanics and thermodynamics of energy conservation, you get a ratio of 8 by 27. So that is called the Page limit, 0.593. So this ratio of the power of the wind and the power of that you get from the turbine, that ratio is called power coefficient CP. So this CP can be maximum 0.593 or 59.3%. Again, it is a counterpart of what is Carnot efficiency in thermal power plant. Similarly, in a wind turbine, this is the limiting efficiency coming from the basic fluid mechanics with law of energy conservation. However, we'll get much less than that, and particularly horizontal axis wind turbine will have more efficiency rather than vertical axis wind turbine. So now, how this wind speed, there is a certain relationship between wind speed. You see that as you see that wind speed changes with the cubic power. That means it will be going like this, but we don't design like this. First we see that this is the minimum velocity when this will produce power, because if there is a very small wind velocity, the turbine will not rotate. So maybe say, let just say here 5 meters per second it starts rotating. Then up to a certain speed, this will increase with the cube power. Then you design the wind turbine for the rated power. If it is a 5 megawatt power, you maintain it 5 power, 5 watt, not you go cubically. There is, it can give cubical power, you can go fast, but you don't operate like this, because finally you have to produce electricity with certain restriction, that this is my frequency, this is my voltage. It has to be synchronized with the unit and the machines it will supply. So we, in a speed range, we operate that the rated power. So at certain speed it starts producing power, that is called cutting speed. Then we go to rated power, and after that when the speed is very high, it will cause stress on the blade. So we don't want to go for that. We stop the turbines. So there is some brake mechanism. So it will stop here. So this is called cutting speed. And actually theoretically it can go like a cube. So it will go like this. But practically only here it is variable, and then we supply at rated power. So cutting speed is where the power generation start. Then rated speed is the rated power generation. Then there is a furling speed or cutout speed. That means when you apply brake on the wind turbine, it will no more give you power. So there is a power curve. So when you buy a wind turbine, the manufacturer will give you power curves. Now there are certain standards like wind turbine classes are there. Again, you have to follow standards like type 1 to type 4. So this, there is some certain reference wind speed, and then for that which are designed. So these are has been now standardized. And as I said, wind is stochastic. Direction of wind can also change. So these are a typical diagram which is called wind rose. So a wind rose gives you the direction of the wind and the percentage of time the wind is flowing from this. For example, if you look at this picture, you can see this from this angle, most of the time wind is coming, because this is the larger fraction. And you can have also scale of velocity. So a lot of data has to be analyzed, and the wind speed measurement typically made about 10 meter above the ground. Small wind turbine heights is 20 to 30 meter. Large turbine height will be 100 meter. Then the gust and lull, so very high speed and all this thing, this has to be considered because these are dangerous for the wind turbine blade. So all these meteorological things are there. This is a picture I am showing you to convey that, see, one blade is being transported in a truck. So this is a very, very huge structure. So as I said, that it is bigger than a plane. One of the biggest thing of technology. So like you can measure by anemometers and release of balloon wind speed. You see that wind affect the physical locality, and from that also people have gathered some evidence of wind velocity and knowledge on wind velocity. Like these are the dunes, sand dunes on the certain areas, and even the lake structure. If you look into the topology, from that you can have a visual indication of the wind speed. Mentioning this as important facts. So I have talked that wind farms, so there will not be a wind turbine, there will be plenty of wind turbine. So the gap between them, like the pitch in the horizontal, I mean in X and Y direction, they are important, because if there is not enough distance between two wind turbine, the energy will be less. The air is carrying energy. Now suppose this turbine extracts the energy, velocity here will be low. So the velocity must be proper enough for the next wind turbine. So this sort of considerations are required in wind farms.
అర్థమవుతుందా? ట్రిక్స్ అన్ని ఉన్నాయా ఇప్పుడు నువ్వు ఆన్సర్స్ రాసినాయి అవన్నీ?
So you see that now my purpose is to draw your attention that in a technology there are so many research issues. It is not limited to a particular area. For example, materials. So most of the time materials are made of glass fiber and carbon fiber, and the blade weight are in tons. So these are up to 45 ton, and this is the length. So data are fit for glass fiber based and carbon fiber based structures, and inside the blades are often hollow. So the design of wind turbine blade is a compromise. Sorry. So the design of wind turbine blade is a compromise between aerodynamical and structural, because aerodynamically it must rotate fast, but it is also a structure, so it has to withstand the stress. So the outer part must be aerodynamically correct. For example, a plane will not fly if the profile is not proper to generate that lift. Similarly, for a wind turbine to work, it must follow the aerodynamic considerations for the outer part, but the inner part, it must provide the strength. So structural consideration for the inner part of the blade. So therefore it is typically hollow with outer geometry formed by two cells, one on the suction side and one on the pressure side. So more structural webs are fitted to join the two cells to transfer shear loads. So for example, fatigue is a big issue in wind turbine. you see load variability and number of load cycle. You know that to analyze the fatigue, the load variability, so maximum minus minimum stress and the number of cycles, that is important. So if you look into that sort of thing, you see bicycle is also subjected to fatigue loading, but car has higher load variability and more number of load cycles. A plane has more load variability and load cycles. Now a bridge is still a complex issue, and in terms of that, wind turbine is a really challenging one to design to withstand large fatigue. So you see there are wind turbine test bench again, which requires huge space and structure, like blade testing at MTS USA. And this surface, the blade surface, so apart from the fluid mechanics part, again the surface you have to be careful. It may need coatings. So a wind turbine can be in a very cold zone, -50, to a hot desert. It is subjected to UV radiation, chemical attack, blood from insects. So blood from insects or feces from birds, these are the things that affects the surface. There will be lightning. So naturally, if it is a huge structure, occasionally there can be lightning. Then there are ice can form over this. The rain will be splashing over it. So all this thing make the protection and coatings a very serious issues. So for which again a code is there, IEC 61400. So my purpose is to draw the attention that this is basically a fluid machines delivering energy, but so many issues are coming there from design to material. So CFD part is itself is a subject of big topic, this thing. So a lot of CFD work is being done, because if you want to understand the basic physics, you have to solve the structure, solve the thing in terms of numerical analysis. So from that, even you can predict what kind of noise will be there, because noise is basically the pressure field. So if you can resolve the turbulence properly, you can predict the level of noise it can give. You can do the performance in terms of aeroelasticity. So not only power, it will be deliver the stress associated stress level. So like you will have a rotating domain with a blade inlet and all this thing. I will not go. These I can skip, but these are, for example, you can have insight from the uh, simulations on the flow structure. So ultimate aim is to understand the uh, power it can deliver and the stress it can have, and also how it behaves during starting and during say closure, and also the steady state operation. So to do that, you can take help of numerics. So I'll skip about the numerics part, but now the pollution is issues are again predominant here. So I'll go to the sustainability lecture. I have some 20 minutes or more than that, so enough time is there. So I'll go to the sustainability lecture shortly. But here in this basic lecture itself, let us see that wind energy, we call it green energy, but yet it is a source of noise pollution, because you see that the machines are running very fast. Okay, running very fast. So therefore there are continuous generation of noise. Then visual effect on surrounding. So it is a fact that many places they object, people in some places object if you put wind turbine. So for example, like we remember that certain places in India, if some new plant is announced, local community, they may challenge that based on the thing that it is disturbing their ecology, or it is disturbing their peace or their heritage. Like airports in countries, advanced countries, are built away from the city because people are disturbed by the noise of planes. Similarly, say I live on a, say suppose in a hilly area, and suppose government wants to, or a company wants to build lot of wind farms, people may say that our scenic beauty is disturbed. So to that, there is a name, not in my backyard, that is called nimby. So there are even today a lot of analysis on nimby, that when people don't want certain technology. So yes, is it may be good for you, but if people do not want that, you have to think twice. You have to also satisfy them, otherwise this will not be technically, it may be technically feasible, but it is not feasible in other ways. It damages the sustainability. So that has to be kept in mind. And effect on flora and fauna. So what happens to plant? So these are again uh, research areas. Like when I have wind farm, lot of um, turbines are put, is it damaging the agriculture there? Is it damaging the grass and weeds? For example, on the seabed there are wind turbines, and research are going on if they are affecting the creatures in the sea, like corals and all. I have seen that kind of paper. But however, uh, like if you want to say green building, so green building is one where the energy, the building has arrangements for generating the energy uh, somehow, so that it can be a zero energy building. That means you don't have to take energy from outside agency to produce solar or wind energy, and that supplies to this thing. So therefore, there are some hybridization for to make green building, etc. So hybridization means you together take wind and solar. And for example, in Dubai, many buildings, I think including Burj Khalifa, the top levels, there are certain solar panels. So this is from a journal source, where you can see these are the solar panels, and here there is a wind turbine is installed here, wind turbine based design. So these hybrid technologies, they are giving uh, a part of the energy that is required for the building. So there are many ways you can hybridize. So as I said, another, for example, one interesting feature, that even we can develop very small wind turbines. So for example, this is a mini fan used in computer. So this is a, say this is a coin. So this fan is of the size of a coin. Okay, so say 2 rupee coin. So this is giving some air. uh, so this is not a fan, this is a turbine, actually wind turbine. So some small source of air, for example, from your computer, the computer is delivering some air to the outside, hot air. Now you can put a such small wind turbine there, and you can develop small quantity of power. For example, this is 10 meter per second. This 2 centimeter mini plant is delivering 5 megawatt. So these are in infancy in research area, but they can be, who knows that one day they can be utilized more cleverly. For example, this energy will be good enough to charge a mobile. So just with a pocket wind turbine, with a small stream of air you can capture, that can fit to a charger, and your mobile will get charged. So if I summarize that what are the scopes of research in wind energy, first of all, we require as much energy as possible. So in all sectors, be it say it is a car engine, or say thermal power plant, or a hydraulic power plant, whatever, even a small, even less than 1%, 0.5% in an increase in efficiency is meaningful in terms of economics and environment. So therefore performance and capacity improvement is always will be there. So therefore aerodynamics, the blade design, new type of turbines, the control strategies, and of course the corresponding electrical part. You need improved generators and better magnets, because you have to uh, extract as much power as possible. Then of course cost reduction is always there, so that is possible by blade design strategy, selection of material, and if you increase the height of wind turbine, you will get more air velocity. Now you require statistical tool to predict, forecast, and life assessment of the wind turbine, particularly say for example wind speed. That is, as I said, that is stochastic in nature. You need to analyze that the wind power potential or wind power density uh, in a better way, and then you need to can apply in zero energy building and energy harvesting, and small turbines are also can be used for micro electromechanical system applications. So so this conclude the first part of my lecture. So now I will go to uh, second lecture. I have divided into two presentations. So okay, I am audible.
Yes, sir.
Yes, sir.
Yes, sir.
So I am going ahead with the continuing this thing, where we'll examine uh, about the sustainability aspect, or in other words, we'll take into stock of uh, the the pluses and minus, pros and cons, positives and negatives of a technology with respect to wind power, and of course which can be applied to many other fields. Because in simple one word, you cannot say this is good or this is bad. Things have a better sides, things have some negative aspects, so you have to weigh it. And uh, one way of weighing this is looking at the sustainability. So so sustainability is now uh, is a buzzword. Everybody is talking of sustainability. As early as 1987, we are telling that sustainability is needs of present without compromising future generation. Like for example, we are using petroleums. So if we uh, use petroleum limitlessly without caring for the future generations, that can eventually lead to a problem that one day our children in the future, they don't have any source. So you have to look into this, that whether there will be enough for the generations to come, whether human being will survive. So the three pillars of sustainability are: sustainability is basically uh, consists of environmental, economic, and social. So environmental, in the sense that we must preserve ecosystem and resources. And economic, unless it is economic, it is not, it will not be viable. So maybe for one day, I'll for my fancy I'll use something, but if it is not economic, I'll not be habituated to use them. So to have something sustainable, it must be economic, and also it must cater to the social issues. So promote equity and quality of life. So society should accept that for the general good of society. So pictorially, we can depict the sustainability in this manner: three aspects of sustainability: social, environmental, and economic. So it is a 3 bottom lines also. Now, sustainability, the importance is it balances resources with planetary limits. So, like we live as of today, we live on the planet Earth. So, the petroleum or uranium or even say lithium, we are limited to the resources in the Earth. We don't know in maybe in future we can mine it from other planet. But as of now, we have to think about the planetary limit. What is the source available to us? Then we must see that economic growth is supported without environmental harm, because you cannot stop the economic growth. We are habituated to a certain standard of living. So suppose air conditioners are maybe bad for environment, but frankly speaking, will it be possible for us to switch up our air conditioners if the temperature shoots above 40 degrees Celsius? Because after some time we will not be able to work. So then what is the point of that kind of sustainability? So uh, we have to think that uh, how we can do something, we can do our own comfort, but then how to prevent the environmental harm or implement technology with do limited harm and promotes global cooperation, social equality. And so the CO2 emissions, we are now keeping track of CO2 emissions. We are because by using renewables. So that is the example that sustainability is having profound impact on us. So United Nations has in 2015 set 17 global goals for sustainability. So, for example, if I talk of wind turbine caters to, for example, these three: clean energy, responsible consumption, and climate action. But let's look into the total thing. What are there in the sustainability? So, this is a very common picture. Everywhere you will see this picture. The Sustainable Development Goal, SDGs. Sorry, just a minute. So this like SDG 01 is no poverty. You can relate to the pictures. SDG 02 is no hunger. 3 is good health and well-being. 4th is quality education. 5th is gender equity. You see, these are the symbols for male and female. Then clean water. So clean water is there. Energy is there. Affordable energy. So not only energy, energy should be affordable by us. Decent work and economic growth. Industry innovation, reduced inequality. So like this, for example, climate action, life below water. So when we are talking of sustainability, we should see that life of creatures in the sea or ocean, they are not disturbed. You see, today you will see regularly that plastics are being consumed by fishes. So or even lower level creatures, they are also consuming some plastic particles. So what level the pollution has gone, and sustainability aims to improve that. So life on water as well as life on land, peace, justice, and partnership for the goals. So these are, there are 17 sustainable goals. But so the importance is that these sustainable development goals are mostly accepted by different countries. They are trying to implement that in their policies. So it gives you a framework to plan the future, to make strategies. So for wind turbine, this is this renewable, it's under the renewable transition strategy. So therefore some financial support from World Bank and all these things are available. So in this context, let me mention of carbon credits. So it is also become a, I think in the lecture there will be certain part in the this course, certain things will be devoted to carbon credits. But it is like the basic concept again we can discuss for say 1 or 2 slides because this is important. Just 1 minute, just power line I'm checking. Just hello. No, sir. Yes, sir. This is, what's the part? अच्छा हम 8 वाले बात नहीं बताते, ठीक है? कौन लेवल का? अच्छा ठीक है, वो टेक्निकल। हाँ 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 ठीक है, हम शेड्यूल देखते हैं तो 8 बजे फोन करते हैं, ठीक है? ठीक है ठीक है। ये कौन कौन लेवल का है? ठीक है, 8 बजे फोन करते हैं। Yeah, am I audible?
Yes, sir.
Hello. Hello.
Yes, sir. You are audible.
Yes, sir.
Okay. So carbon credits, basically the one of the agency that leads to global change in temperature is the carbon dioxide. So now there is a concept of carbon credit because uh, countries are realizing that we have to limit the global temperature rise. So if certain measure that can reduce the carbon, that is you can you can trade that. For example, suppose a company or a country is unable to reduce the carbon level, but some other company or some other country they are reducing the carbon level, so you can that they can actually trade. So international agencies will accept that as a contribution to the environment. So country X is unable to reduce that much, but if country Y is doing that, they can sell that. So 1 metric ton of CO2 is basically 1 carbon credit. So this has become again commercially viable. At the same time, it is reducing the pollution. So there are some ethical concerns maybe because X is not reducing carbon, Y is reducing. So and X is taking the credit by paying him money. So there may be certain ethical issue, but at the same time, it is promoting the reduction in carbon level. So the technologies which reduce the carbon contribution are tradable in the forms of carbon credit. So now companies and producers they have to have accounting for that, and there are agencies for the carbon credit monitoring, and there is a carbon market. So in other words, by reducing pollution you can take part in the carbon market. So your strategy in reducing the carbon dioxide sorry carbon, so it does not mean only carbon, means anything polluting and depleting ozone layer or contributing to global warming like sulfur, they are also taken care by some equivalence formula. So so that can be traded as a commodity. So now coming back, so at the same time it is important to also, because we are talking of sustainability, it may not be directly linked to today's topic, but it is important to cover that water usage, because water is one of the again important item in terms of sustainability. And we are most of the time there is excessive wastage globally and locally you can see. So from you see that fresh water use has gone up by six times from 1900. So like particularly say with technological growth, this has become a big challenge. I am particularly drawing your attention. You can study this in available resources that AI is one of the biggest contributor to the water drainage. You see that, for example, one ChatGPT session, it takes about 0.5 liters water. Training large AI models, it can take up to so much gallons of water. And the data center, they require huge cooling. So this data center capacity will grow by 160% by 2030 because we are having more and more data, more usage of AI. So they are again all connected. So they are taking a lot of resources in terms of water and energy, and these are important to keep in mind when we talk of sustainability. So coming to wind turbines, these wind turbines are renewable, low CO2 emissions, and various energy demands. It can accommodate that and supports sustainable development goals 7 and 13. So clean energy, economic equity, all this thing. But then we'll have see that. So like that, there is a something called index potential. So per unit power, how many kilogram of say some pollutant. So this is 3 index potential. You can see one is the acidification potential, one is global warming potential, and blue is water depletion index. See three technology. So one is coal based power plant where carbon capturing is not there. When carbon capturing is there, and wind turbine, you see that water depletion index. So coal based plants that requires a lot of water. If I do carbon capturing, the relatively less water is required. Index is relatively less. Then global warming potential, you see, of course, we have a huge global warming potential for coal, and coal with carbon capture also. The global, you are doing carbon capture, so global warming is relatively less for coal. But for wind turbine, you see only a little bit of acidification potential because of the materials it require. If you take up their manufacturing, so all these things, some acidification potential is there. So you can see that in terms of water usage, there is no water usage, there is no global warming generally in the general sense. So this looks to be very attractive. Of course it is attractive, and that is why it is growing very fast. Now again, from the economic side, if you look into that, the levelized, this is showing you cost of electricity. This part is somewhat difficult to read. Actually it is shown that how cost of electricity is estimated. So if you have a power plant, the cost of this thing will depend on what is called the capital cost, running cost, and this material cost like fuel cost and all. So if you see that this is 2010 and 2022, so cost of electricity. Now see in the this, you see that 2022 wind farm, the cost of wind and cost of coal is almost par. See, it is in terms of US dollar. So cost of wind is say 0.08 and is only 0.012 less for the fossil based plant. And for offshore wind farm, it is still less. So if you have a offshore plant, your cost of electricity over the years for wind has come down. So economically, it has becoming really a very viable alternative in terms of cost of electricity. So previous slide, we have seen that environmental potential wise, this is showing the cost of electricity. But still, so that means it is very good, very green. So where is the catch? Should we be complacent? Is there no scope for further improvement, or whether sustainability is not an issue here? So we'll find that talking of social, environmental, and economic issues, like let a lot of environmental concerns we can talk. Like for a wind turbine plant, the soil erosion, the effect on wind profile, hazardous metal, noise pollutions, all these are active part. Social concerns, human noise pollution will be there because the turbines runs fast. Then I talked of NIMBY, that is not in my backyard, I don't want it. So many people, many locality consider such turbines as a nuisance to scenic beauty, or think it as a visual pollution, and also, of course, impact on wildlife, birds, bats, insect. So we are talking of social concerns, but then it also has social benefits. Like it is from a paper, I got the statistics for job creation. So certain countries who are gone for renewables, you see that lot of job has been created. This is jobs created in thousands. So France, Germany, Denmark, you see Spain, Sweden, who has made a lot of wind turbines or wind based plants. There are a lot of job creation. So it is a social thing, economic thing. That is one of the better point. But then, this slide I should have been shown earlier, that size of the wind turbine that I have already told. But the issues we are discussing, issues that environmental, we have to wildlife, noise, land use, economics, high cost of maintenance, social is the nimbism and visual impacts, and material also the non-recyclable blade. So blade waste is a problem. So this summarize the problems in a effect of fluorine fauna. So because they rotate very high, there are a lot of bird mortality, insect mortality, and even when they are in the seabed, their studies are not conclusive, but they may have some effect on the corals, coral beds, and other creatures. So there are works on available works on bird mortality rates. So that is not very limited number. A lot of birds are dying because of the wind turbines. So these are statistics from a US paper. So California, then Eastern America, total US, you see the total number of turbine 44,000, and the number of bird mortality, what is the period cover in 10 years period, it covers the like something like 2.5 lakhs birds have died, okay, because of the accident due to turbine. So that means there are issues even in a green technology. Certain questions comes. So how to evaluate sustainability? So of course, carbon footprint I have already mentioned. So if it is reducing the global warming potential or water depletion, that is becoming very good. But for that we need to do life cycle assessment, then carbon calculators, and also you have to do the social impact assessment. So economic viability, within that comes cost component of capital operation, then cost of energy, fossil fuels, all this thing. And so these things comes into the picture for economic viability. So as we see that cost of electricity is really reducing, but then waste disposal and other costs, that also you have to keep into account. So like waste disposal is again a big challenge in such technologies. So the blade and material, for that, 3 types of recycling methods, if I want to mention, they are mechanical, thermal, and chemical. So you can mechanically destroy them, use thermal process, like you can burn them or incinerate them, and chemical treatment. So but we need really eco-friendly and recyclable materials. So there are mechanical, chemical, and thermal, these way recycling can be done. We can promote sustainability by reuse of material, like cement production, electricity generation, reuse of blades, and disposal. So just if I do plain disposal, I can use it landfill. So like landfill means filling the earth where we want to build some structure. Maybe you can just put the debris there, and incineration. So they are just straight away disposed. But reuse and recycling, they are better alternative. So you see that I have already told that wind turbines are blade, very huge structures. So this is a part of a blade. Okay, so this is the part of the nacelle of a wind turbine. You see how big is this? That is having a 35 square meter area. So a Holland-based company, Blademate, they have this way. They are reusing some of the blades or wind turbine components to make, for example, such a living room. Okay, so this is the part of the base of the wind turbine. I mean, that is the nacelle region. And then, for example, these are the wind blades. So they cover some part of the playground, so people can skate over them. So there are clever ways of utilizing that will eventually come. So recyclable blade materials, better design, improved site planning. These are the way of improving sustainability. And also technology advancement is important. So like see, blade design, if they are inspired by biology, which we call biomimicry. For example, a plane does not fly like a bird. So plane wings and bird's wings are different. So similarly, turbine, if I can have some movements following the way bird moves, maybe I can generate more efficiency. So that is a field which is called biomimetics. So that can be used. Some experimental level things are being made, but eventually that can be a big thing. Then control of airfoil and turbine optimization, they can lead to better efficiency. So therefore better performance. That means less carbon footprint. So even there are certain techniques like you can use guide vents, deflectors, so or alternate blade profile. For example, this is suppose a wind turbine rotor. So around this, if you make a duct, you can see this is the power coefficient. So this is without a duct, and if you make a diverging duct like this, you can see that performance is increasing. So that is called augmentation or enhancement of performance. So that is also contributing to energy pipe. That means whatever small gain you can get, you should not neglect that to develop the power, because ultimately little drops of water and little grains of sand make the mighty ocean and the pleasant land. Whatever contribution is there, they are welcome, because they reduce the carbon footprint, and eventually small contributions in power saving can lead to large offset. So there are a lot of innovative design coming up. Like recently I was saying a design by Riam Wind. This is called wind lens. So personally I have not gone into the technical details of this, but you see they are claiming that the arrangement of these turbines are such that energy is more focused, efficiency is enhanced. So such things, such innovative designs can be contributor to power. So like there are a lot of tools for looking into the sustainability. So like you have heard of multi-criteria methods, MCDM techniques for evaluating something where there are issues. So for example, I am presenting something called a spider diagram. So like if I compare a coal-based thermal plant with wind energy, you see that these points are certain aspects of the technology, like water usage, greenhouse gas emission, noise, loss of flora and fauna, land usage, social issues, cost of primary materials, waste disposal. So like this line, wind turbine, you see cost of primary material is wind, so cost is zero. You don't have to pay for getting the wind. But coal, there is a cost. Now waste disposal, this has this is say for example from coal based plant, there it is more problematic. Next is water usage. Again water usage, this is having use, actually again this should be minimal, less water usage. Here water usage is more. It is emitting greenhouse gas. Here greenhouse gas is less, but it is more noise. Wind turbine is somewhere here. Loss of flora and fauna for wind turbine, it is more. Land usage, maybe it may be more, maybe less, based on design of plant. So there are two colored areas. These areas give me an idea of sustainability. So there are many issues which we do not readily think of. For example, wind turbine, they require strategic materials. Like you know that for car, we need the materials for the chips of the car. Today's automatic cars, they require a lot of chips, which require strategic materials, lithium and other type of things. So rare earth materials, which are now very costly. Uh, but wind turbine also similarly, those sort of materials are required, because wind turbine control issues are there. For example, a wind turbine nacelle must move in the direction of the wind. So that is for that we require rare earth materials. So mining rare earth material is a big issue. So that again has some pollution angle, economic angle. So we have to think of that also if I want to properly assess the sustainability. For example, you know that China is controlling most of the strategic materials, and that is having a profound impact on the supply of chips required for automatic cars and computers. And there are a lot of trade negotiations. Anyway, my point is there are many issues here. Only say 1 2 3 4 6 7 7 8 issues are highlighted. So you can have a comparison of two different technologies, but again this type of comparisons are very difficult in one go, and better strategies should eventually come up. But we have to keep in mind that sustainability is complex, and we must uh, mm, assess it. The assessment technology must change. So overall, if I talk of earlier, I have talked of wind turbine, progress in wind turbine and the research areas in wind turbines. Now here I focused on sustainability, and we found that while wind turbine technology is a great renewable technology with lot of advantages, lot of potentials, lot of scopes in research, some sustainability issues are there, which will continue to be resolved in futures, and for which we need assessment tools like LCA kind of things. So uh, that is what is the part of this thing I wanted to tell. I contribute here that renewable energy, we rarely think of the renewables uh, negative sides. So finally, I thank Professor Dr. Deepak Mondal uh, uh, for his invitation, support, and also the staffs. Madam Boisali from there is continuously, I can see, find her working, and also the principal sir and the staff from Samstipur, who has really arranged for a great program. And I also thank some of my collaborators. Uh, they are in Satyajit, Dr. Mujibur Rahman, Miss Shangjukta Banerjee, who has helped me in some of the research. And finally, I thank you. Thank you.